Hey guys, hope you're doing good. This is a talk on refactoring I gave to Wyshlist. Let me get started with my slides. You guys see the slides, right?
Yes.
Cool. So the way this is structured, I have a bunch of slides. At any point, if you don't understand, interrupt and ask me. There are no stupid questions. If you didn't understand something, it means I could have explained it better, right? And the subsequent parts of the talk will build on what we discussed earlier. So if you didn't understand, just interrupt me, because otherwise you lose track. And after this, I will walk you through some actual refactorings I have done. What's refactoring? It's changing the structure of code without changing its behavior to improve design or code quality. What is not refactoring? Adding or removing features, changing the way features work, improving UX, supporting more platforms, offering an API, offering an on-premise product in addition to a cloud-based product. All these are not refactoring. Some people would ask, can't we instead design it properly the first time? No, because we are not perfect. And when you try to get it perfect, it leads to over design because we don't know what's going to happen. And if we tell ourselves we can't refactor it, we'll feel the urge to do it perfectly. And perfection actually is over design. You need to design for what you need today and some amount of extensibility, but not too much. Over design makes it hard to understand and hard to change. I've gone through code bases where every class only invokes some other class. No one does any work. Trying to get it perfect also leads to long code reviews because this is the only chance we have. So everyone will try to make it the best that it's possible, which is a good intention, but it can slow things down to the extent of making it take a month to add two fields to a dialog box. Requirements also change. It's not like a building where the requirements are fixed, right? Software is malleable. So that's a need for refactoring. So instead of trying to do it perfectly, we should work in iterations. Do the best you can today and refactor when needed. A metaphor is writing with a pencil where you can erase and change it, not a pen which is permanent. Code that's never been refactored is usually bad code. An analogy is maintenance. If you have a car, it needs maintenance. You need to change the oil, you need to rotate the tires, you need to align them, you need to change the engine oil, the brake fluid, etc. If you don't, your car will fall apart. Code similarly requires maintenance, and refactoring is a kind of software maintenance. Sometimes people don't understand the value of refactoring, and they say, we don't have time to rewrite again and again things that are already working. That would be true if refactoring didn't add value, if it didn't make it better, right? You're not doing it for the sake of doing it. You're doing it because it will be better. What is not a valid use of refactoring? We didn't have time to do it properly the first time. This especially happens in early stage startups, which are dominated by non-technical founders, where they keep yelling at the team to do it yesterday. And saying, okay, I'll just do something bad and I'll refactor it later is not a good idea. So I know a startup where they had a billing Java file, billing.java, and they needed to make changes. They didn't know who was invoking that class. So they copy pasted the entire class and made it billing v2. Then someone else came, they made it billing v3. They eventually reached billing v7, and no one knew which of them are being used and which of them are not. So we'll make a mess and fix it later doesn't work. So refactoring is not an excuse for doing bad work the first time around. You do as much as you can right now, given what you know, and then you improve it later. Refactoring often changes the interface of a function, class, or module. These are the same things at different levels of zooming. If you zoom all the way in, the smallest unit is a function. If you zoom out, you have a class which consists of many functions. If you zoom out some more, you get a module which consists of many classes or a subsystem. So all of these have an interface and an implementation. Refactoring often changes the interface. It changes the implementation also, but it doesn't just change the implementation. It changes the interface, which means you need to go and change the callers. Refactorings that change only the implementation, like a while loop to a for loop, are atypical. Refactorings often are driven by coding and design guidelines, and every project should have these two, coding guidelines and design guidelines. A coding guideline might say things like make things const as much as possible. A design guideline may say things like minimize the surface area of a class, the number of public methods in it. And these often drive refactorings. So if you have a coding guideline that variables that shouldn't change should be const, and you notice that they are not, then you go back and bring the code in sync with the guideline by doing a refactoring. When you refactor, you should respect the original design intent. A code base may be intentionally designed in a certain way, right? You need to respect that when refactoring. For example, if someone is using the facade design pattern, where you have one class behind which you have a whole bunch of classes which are not used directly, don't expose them, because then you are damaging the intent. You're damaging the design, right? For code to be understandable, there need to be certain design principles or decisions that are made and respected, right? So, I mean, if the decision is not working, you need to change the decision. That's a different conversation. If a facade turns out to be the wrong design pattern, of course you can remove it, right? But as long as you keep it, you have to respect the original design intent. Don't randomly without understanding. Typically, the way it happens is not someone intentionally breaking the design intent, but they just don't know. So that shouldn't happen. You should separate refactorings into small commits. So if you're renaming a class and making a function private, don't cram both of them into one commit in Git. Right? Don't be lazy. They are logically different. Because someone could agree with, say, making the function private, and they could disagree with renaming the class. So small commits are easier to self-review, and before you send out code for review, before you open a PR, you should self-review by looking at the diff side by side. And that's easier if you're doing one thing at a time. They are also easier for others to review. They're less likely to introduce bugs. I have introduced bugs by making multiple refactorings in one commit. When I separated them out, the bugs were obvious because so many things were not mixed together. And each design change became clearer. So when I renamed the class, I was able to evaluate the change I made better. Is it a good change? Is it change for the sake of change, or is it an improvement? Is there some other name that would be better? Or is this class even needed in the first place? You're able to evaluate all of this if you make atomic commits, small commits. And if you do introduce a bug, someone can go back in Git history using Git bisect or manually checking out different revisions and testing it. If you combine multiple things into one commit, it becomes harder to track down when a bug was introduced. So that's why you should have small commits. You should have small commits regardless, all the more so for refactorings. Before committing, compare the old and the new designs. Ask yourself, is the new one better or just different? If it is different, revert it. Avoid unnecessary churn. Don't be lazy. Don't say, look, I've already implemented it. Why revert it? Don't do that, because people understand how the previous code works. Now, when you change it, they have to understand how the new code works. And if they put in that effort, they should be rewarded with a better design. If you're just changing it, don't do it. Because somebody else may disagree with it, and they may make a different refactoring. So it can even cause the team to lose confidence in the concept of refactorings if we do them unnecessarily. Careful not to refactor. It is what it sounds like. It is when you try to refactor but you mess it up. Right? So doctors have a principle. First, do no harm. If someone goes to the emergency room, they don't randomly give some medicines, right? The first rule is do no harm. If you're not sure, even if the patient is in a bad state, kind of let him be, think for a minute, right? Don't rush and do things that can cause harm. So we should always approach refactorings with humility. If we can't identify an improvement, or if the improvement comes with its own severe downsides, don't do them. Leave it alone. Maybe after a day, after a week, after a month, you'll come up with a better idea to fix it, or someone else will. But don't cause problems while refactoring. It could be bugs, it could be performance issues, it could be making the code harder to understand, right? Don't do harm. Any questions before I move on to the code samples?
No, not from me.
Guys, speak up.
No, nothing from my side. It's pretty clear.
Was it clear? Was it over the head? Was it so obvious that why is he talking about this?
No, it was pretty clear up till now.
Cool. So shall we move on to some code samples? Does anyone have any comment or a different approach to refactoring that they may have?
We can move forward.
Cool. So this is a FutureCam repository. FutureCam is my prior startup, as some of you know. It's an advanced computational photography app, an iPhone app that processes 1 GB of data every second on the phone, not the server. And when the startup was alive, we could not have as good code quality as we wanted because of time pressure. We still had excellent code quality by startup standards. After the startup failed, the tech part worked, the business part didn't work. So the startup failed. After that, I took it as an opportunity to refactor the code. This is a rare opportunity because we rarely get access to real code. Usually it's some exercise someone has done. They've just created a project to illustrate refactoring. So usually we don't get an opportunity to do this or to follow along because the code is confidential, right? It's not posted on YouTube or anything. So anyway, so let's start looking at these.
Karthik, can you explain what it was doing? What FutureCam was doing?
Yeah. So FutureCam was basically for photographers. The idea was computational photography to do in software what an SLR does in hardware. So for example, you can take a photo and change the shutter speed after the fact, like this. If you're shooting with an SLR, you can't change it after the fact. You choose some settings and you may get, let's say, this photo. If you don't like it, if it is too milky and too abstract for you, you want a little hint of some texture, you can't change it after the fact. Here you can.
Got it.
And you have a light trail video. The thing above is the Bangalore metro. And you can see how the traffic is leaving trails. You can control the light to create this silhouette effect. The thing in the background, we are painting with, it's called light painting. You paint with light. This is a smartphone torch. You have a time lapse which can speed up the passage of time. You have a burst mode that runs at 30 frames a second as compared to Apple's 10. So you can see each flap of the wing of the pigeon. Then we have a computational zoom where we use our algorithms to zoom better. This is the iPhone. This is FutureCam. And this is shot from the 7th floor to the ground floor. So you can see how much it was able to zoom with less degradation. We have a night mode. This is the iPhone. This is ours. And you'll notice 3 stars here, as well as condensation from a jet. It also captures more detail. This is the iPhone. This is future cam. And you can also remove crowds. So if you're recording your friend in the blue shirt in front of a monument or some public place, and there's a crowd going by, right? There is me in the yellow shirt coming in the way, and there is a person behind. All these people are photobombing. FutureCam can detect and remove the crowd. So if you notice, you have this guy and his reflection in the mirror, both are removed. It has some more features. So this is the app. It's an iPhone app. That's what we are refactoring.
Okay, this was doing most of the current smartphone features.
Yes, 3 years
When
back,
okay,
2017, 18, 19 timeframe.
okay, and is it purely compute like manipulating the photo, or is there some made up stuff?
No, nothing
Let's
is
say
made up.
okay,
Like with AI algorithms, sometimes they guess what should be there, right?
yeah,
And they
yeah,
insert it. No, it doesn't do that. So it can never make a mistake.
okay, okay,
Shall we move on to the refactoring, the code?
yeah, yeah.
Cool. So we have a whole bunch of commits here. So if you have a task in your task tracker, in this case, it is GitHub issues, but it could be Jira, whichever it is. Link the commits to the tasks. So here, this is about declaration order. So we are sorting in decreasing order of access, where public comes first and private comes last. The reason this helps is people who are using the class can just read the public part of the class, not the private thing. So that makes it easier to understand. And it was getting hard to understand because different classes had different orders. So that's all this does. There's nothing much to go through in the diffs. Stop me anytime you are kind of not following. This is again the same thing about ordering. This is a design guideline to use containment instead of inheritance. This will simplify the inheritance hierarchy. It will avoid the yo-yo problem. So in fact, I have a video about it. Let's see if I can find it, otherwise we'll move on. The cons. This is how the inheritance hierarchy was. You have a function which is overridden by something and it's calling super. And this function shutter button pressed called stop recording, which was again overridden by the subclass and calling super. By using containment instead of inheritance, I was able to make it simpler. Compare this with this. So here we have a mode which is ultimate base class. A mode is a mode in a camera app like time lapse mode, video mode, photo mode, etc. And some of the modes would record a video, both the video mode and the time lapse mode. So we had a class here. Let me show you the inheritance hierarchy first. Here, this is how it was. You had a mode and you had different modes. You had 4 modes. These 2 modes, light trail mode and time lapse mode, would record a video. So they had a common subclass, abstract video mode. in this refactoring, we removed them. So now all four modes directly inherit from mode. Clear so far?
Yes.
Yes.
So when I say use containment instead of inheritance, this guy abstract video mode is being removed from the inheritance hierarchy and converted to a helper class. It's no longer a superclass. So
Karthik? I'm not really sure what do you mean by containment instead of inheritance. What's the containment?
So containment means you have a helper class and another class invokes it. So, okay, so let's take a step back. Why did we introduce this abstract video mode? Because you have two modes that capture a video and they have some logic in common, right? I didn't want to repeat that logic in both the classes. That would be bad design. That's why I put in a base class originally, right? That
Okay.
was causing more complexity than we like, which is this
Correct,
confusing.
correct. Yes.
So we didn't like that. We wanted to fix it. So now we made it a helper class called video mode helper, which is outside the inheritance tree. It's on the side. And these two modes are invoking it like a helper class.
Okay, got it.
So let's go to video mode helper. This is abstract video mode. And it became a separate helper class. So abstract video mode, if you remember, is this middle guy here.
Uh, got it, got it.
And earlier it was inheriting from mode, which is here.
Mm, okay,
Now it's a helper class. Helper classes don't inherit from any class, nor do other classes inherit from them.
correct, correct, got it.
So now if you look at the different modes like light trail mode, earlier it was inheriting from abstract video mode, right? Now it is inheriting from mode directly. Let me know if I'm moving too fast. I'm familiar with this code, so it may not be understandable to you. Just tell me to slow down. So here it is inheriting from abstract video mode. Here it is inheriting directly from mode. Light trail mode inherits directly from mode. And this function stop recording is no longer being overridden because it doesn't have a base class anymore. It has a base class, but it doesn't have any functions. It's more like an interface in Java or a protocol in Python. It doesn't have any implementation. So we can walk through this more, but it's just mostly changing stuff to make it work. Similarly, time-lapse mode used to inherit from abstract video mode. Now it inherits directly from mode, and it creates a video mode helper class and uses it by calling functions on it instead of calling on the base class. Right? This guy became a helper. Everyone clear about this commit? Shall we move on?
Yes.
Yes.
Cool.
Yes.
And when you change things, remember to update the comment. So this one says something. Now you have to say a helper class. Right? It's no longer, it used to say a mode because it inherits from mode. Now it's not a mode. So, when you refactor, you should always update the comments. Otherwise, they'll get out of sync with the code. And refactoring should always have a justification. You shouldn't be doing things randomly. You're simplifying the inheritance hierarchy. This one. This is obviously easier to understand than this. You're avoiding the yo-yo problem, which is this. So we call it yo-yo because it goes up and down the inheritance hierarchy, base class to super class. Sorry, subclass to superclass. And in the earlier design, we also had a runtime failure. Now we made it a compile time failure. So, all the justifications or the implications of the refactoring should be mentioned here so that people understand why and they can see that it's clearly better. Like no one would say this is better than this, right? Moving on. Inline a single use function. So you have this function processed photo output, which was called only once. And it was making the code harder to understand. Because if you look at all of it, if you look at this entire file, if you have a function, you have to look through the entire file to see where it is being used. And it could be used in multiple places. When you inline it, it becomes easier. You know that it's used only here. Of course, inlining should not be done with functions that are very complex. Or if after inlining it, this function becomes very long, like hundreds of lines long. A good guideline is for a function to fit in one screen. But anyway, this was small. You had just some verifications or checks. The actual logic of this was only one line. So it's not like it's becoming much longer by inlining it. So in this case, it was worth it. Refactoring should be like this. We have some unused classes called NS key value observation. We are leaving only one behind because in that case it's needed. There's no other way to do it. But in every other case, we have moved from using NS key value observation to a better way. This is an Apple API that sends you a notification whenever any field of an object changes. So you register an observer and you get events saying A changed, B changed, C changed. If a class has three fields, A, B, C, three instance variables. Unfortunately, it's prone to a lot of bugs and crashes and undocumented behavior and threading issues and so on. So we got rid of it. But somehow this variable was still left behind. So in this commit, we got rid of all of them except one, which is necessary. So often refactorings can't go to 100%, they have to stop at 95%, which is okay, just document it because it's all about being pragmatic, not a purist. And because it was private, it was much easier to remove it, knowing I can't break anything outside this class. So I can look at the code for this class, check whether anyone is using observations, just command F will do, right? Because it is private. And then you can confidently remove it. So when you make some refactoring, such as making things private that should be, it makes other refactorings easier. That is one thing. Yeah, more of the same. So removing unused code is a common refactoring. In iOS, when you run low on memory, iOS sends a memory warning to you, which is an event. Unfortunately, over the years, it has become less useful. So the original idea was that as your memory use increases, iOS sends you a warning so that you can reduce your memory usage before your app is killed. Unfortunately, nowadays it is sent in the last instant before it is killed, so you don't have enough time. So you don't even need to worry about it anymore because you can't do much. So always clean up code because you may do things with a certain intention in mind and they don't work out. Just remove them, right? Clean it up. So here, let's see what we are doing. Yes, so different modes have different aspect ratios. Like photos are typically 4 to 3 aspect ratio. Videos can be 16 to 9. So that is what this code does. If it is a video mode, then you return 16 by 9 or some aspect ratio which is suitable for video. Otherwise, you return an aspect ratio suitable for a photo. Typically, this is a design smell. A design smell is something that is an indication that something is odd, because you should not be writing conditional code based on the type of an object at runtime. You shouldn't say if this object is an instance of X, do something, otherwise do something else. Right? It's a design smell or a code smell. It's not, so it's an indication, right? It's like if you're eating food and it stinks, you're going to stop and check before you eat it, right? So it's like that. It should tell you something and you should be paying attention. A design smell is not always a guarantee that things are bad. Going back to the food analogy, some food like sambar can often smell even when it's not spoiled, right? So a smell is just an indication that you should observe. It's not a conclusion. It's an indication for you to pay attention. And this is an indication. So instead of doing it this way, we have overridden it. The base class mode returns 4 to 3. The video mode class overrides it to return 16 to 9 or something. This is how proper object-oriented design is done, not by writing if statements based on the class type. So this is one commit. Add a to-do. Sometimes you find a problem and you can't fix it immediately. Just add a to-do so that you don't forget it. So basically, the iPhone camera can be in different modes at the hardware level. So it can have a different resolution or a format, right? You can use the wide angle camera or the telephoto camera. So all this configuration should be done atomically, which is you change everything at once. If you do it non-atomically, there's a risk that the intermediate state you are going to is not a valid state, or something can go wrong, causing a slowdown. So I'll give you an example. The front camera in older iPhones doesn't have autofocus. The back cameras do. So if you're moving from the back camera to the front camera, you should change the focus mode from auto to manual. If you try to force the front camera to use manual focus, you'll get an exception and a crash. So this is an example of when you want to do it atomically. You don't want to be in a state where you're using the front camera with autofocus, even if you're going to change it in a millisecond, because in that millisecond, you're in a bad state, right? This may or may not be exactly how the iOS camera works, but I just gave you an example to illustrate. We also had poor division of responsibility earlier. You have two classes. You have a session and you have a device. And earlier, the session class was also accessing the device properties by calling functions on it. This made it very hard to understand. So in this refactoring, we have put in place a clear division of responsibility. The session no longer does anything with the device. The earlier code was harder to understand because things were getting changed where you didn't expect. Yeah, I won't walk you through the iOS specific details of why this change is atomic. because unless you are interacting with the iOS camera at a low level, it doesn't matter. So basically in iOS, when you make a change, you call begin configuration, then you can make any number of changes. And then you call commit configuration. And then all of those are applied atomically. In the previous code, we were calling it multiple times, which was causing it not to be atomic. So if you call begin configuration, do something, commit it, then again start begin configuration. Now you have two atomic changes which are not atomic together. So we removed these calls that were happening in the middle. Swift has optional types. So you can do something like double question mark to indicate it can be nil. But you can also use -1 to indicate an invalid playback duration. So this is for a video. Is it a 10-second video or a 20-second video? The duration of the video. Obviously, you can't have a -1 second video. So since double already has -1 to indicate an invalid state, I didn't want two states like this, nil and -1, because this imposes a burden on every class that's consuming a double question mark, an optional double, to check both the cases. And I have seen bugs where someone was using -1 to indicate that it's invalid. Someone else was checking only for nil, and they thought it's valid, and then it crashed or did something maybe, right? Did something like a bug or a crash or unexpected behavior, right? So we don't want two ways to model something. We want only one way. So that is what I've done here. We had an optional value which was, this is similar to question mark. This is also optional. Here it was initialized to nil. Here it was initialized to -1 to indicate that it's an invalid timestamp. Because this is Unix time, it can't be negative. Often a change is spread over multiple commits. Here, here, and here. So that's okay. You can spread a refactoring across multiple commits as long as each refactoring leaves the code in a valid state. You shouldn't introduce bugs saying I'll fix them later, or mess up the design saying I'll fix it later, right? It should be improvement. So the code after this commit is better than before. The code after this is slightly better. Code after this is even better. If you are doing this, you need to make sure that after making two commits, you don't go back and say, oh no, that was a bad idea. Because then you have to roll back and the revision history in Git becomes messy. In that case, you should do it in a branch and then merge it to master. Update beta session.swift. This is not a good commit message because even in this screen, without clicking, I should be able to tell what it is. Okay, there were two changes and I couldn't come up with a better summary than update beta session. So when you can't, you can use a generic description or summary like this, but when possible, make it clear. What does this do? Yeah, so the iPhone camera can either capture a photo or a video. If you ask it to capture both at once, it will crash. So what this code does is, when you add an input, So basically in iOS, the camera has outputs like a photo output or a video data output. When you add a photo output to the camera, you're telling the camera that this is the output I want. When you add a video data output to the camera, you're telling the camera to configure itself to provide video. So that is how you configure it based on the output you've added. And like I said, you can't have both because the camera will not know whether to configure itself for a photo or a video. It will crash. So that is why in this change, when you are adding an input, I'm iterating through the existing inputs, this input, and whichever is not the argument, I'm removing it. So that way, when I add a photo output, input or output, whichever, I think the logic is the same for both. The other one, the conflicting one, is removed. So if you look, there are two functions: add input, add output. For add input, this case was already taken care of. A conflicting input was removed. So in this commit, I just moved the code below. I didn't really change it. But add output somehow was not taking care of that case of a conflicting output. So that is why I added it. And that is why the description talks about output. It doesn't talk about input because input was already taken care of. And this illustrates another design principle, which is consistency. You want to make sure that you are not deviating unnecessarily. Somebody new to the code might expect add input and add output to behave similarly. And if you conform to these expectations, the code will be intuitive and easy to understand. You shouldn't make them inconsistent unless you have a strong reason to do that. That is one. I think, okay, so let's just look at one more and then we'll stop. Guys, what do you think? Or do you want to go over even more? Okay, I'll take it as one more. Someone was speaking?
Yeah, I said you can. I think you can take questions post that.
Cool, we'll do that. We'll look at this only because I like the description. Deconvolute session.add input. It was convoluted, hard to understand. So what were we doing here? So firstly, one addition and 19 deletions, right? This is the balance. You want to see more red than green because the code is becoming smaller, and everything else being equal, smaller code is easier to understand. I'm not saying it always is. You shouldn't try to come up with smart ways to cram so much into one line of code, but often it can be. So you have this remove function that does a whole bunch of stuff. I was able to write it in a simpler manner. And these private variables, these local variables are no longer needed. I don't think there's any change here. It's just the, yeah. So I've removed this function, rewritten the logic in a different way. And also, if you look at the older code, it hard codes the cameras that iPhone can have. It has a wide, tele, front, and ultra wide. Let's say the iPhone 16 or 15, whichever the 2024 iPhone will be or 23 iPhone will be, has two ultra wide cameras or two telephoto cameras, say one with 2x zoom and one with 10x zoom. Then this code won't work because it is hard coded. This code will work because it's not specific to the cameras. Or maybe they'll add a new black and white camera, which works better for black and white photography. Who knows, right? So you want to keep it generic. You don't want to convolute the code to keep it generic, but sometimes you're able to write code which is both succinct and generic, works with and extensible, works with any hardware change, or at least some hardware changes. All right, then that's all the slides and the code changes. Happy to have a conversation or take questions.
I think I have one question regarding the last point that you made. Like we have also experienced this about a generic part, right? So
Mhm.
what is the correct way to decide like this can be generic or this should be generic? Is it based on the requirement or what can be the driving factor behind that thought?
So typically, don't specifically go and make it generic. Don't say I have to make this generic, because when I did that, the code turned out to evolve in a way different from what I anticipated, and
As
I
it,
could not foresee it. So what I thought was generic code was often convoluted, over-engineered code. Later, I looked at it and thought, why did I do all this complex, unnecessary stuff?
okay.
For example, I may have introduced a factory so that the class that is being instantiated can change, right?
Mm-hmm.
But later on, the change that was made, it did not work with a factory because there was a completely different class that had to be built with a different interface. So while instantiating that, you had to pass in other objects as parameters to the constructor or the initializer.
Yes, so technically, does it depend on the functionality that we expect in the future, or that's what, right? Like when
Right.
do
Right.
we
So
decide?
right.
Yeah.
Right. So what I was trying to say was, first point is, don't try to foresee what's going to happen. Right?
Okay.
We can't foresee unless you know if there's already a ticket in Jira saying we need to implement this next week or next month. That's a different conversation. But
Correct.
otherwise, right? So I'll give you an analogy. Suppose you have a car. You say, okay, why don't I make it so that we can make it an SUV so that we can go off road? Now it's more generic.
Uh,
Tomorrow, if the requirement comes to build an SUV, it'll be very easy to do it because I've already designed for it. You may think that, but the requirement will call for a submarine.
Makes sense.
So, in fact, now what you have a car that consumes more fuel
Correct.
and costs more to build for no reason.
Correct.
So the first step is not to foresee. The second step is, if you see signs like these hard-coded things, these are a good indication that you have unnecessarily made it specific.
Correct. Correct.
So here what I was trying to do, we have 4 cameras, right? We are iterating through all of them and checking if that is not the camera that we are adding, remove it. But
Correct.
then I realized, instead of iterating through a hard-coded list of cameras, I can go through all the cameras that are here and compare
Correct. Makes sense.
instead of hard coding. So hard coding is one example. The other thing is, when do we make it generic? Um, like I said, right? If you know what users need, which is very hard, if you know what is required to be built a quarter from now or a month from now, right? Not in a vague sense that, hey, we need to have some data export feature, right? But in a specific sense, right? Like, okay, this is how it should work, right? There should be one button. When the user clicks it, all his data gets exported from the database. That's like a specific version of a feature,
Correct.
right? So if you have a specific version that's already planned out, this is where you should talk to the PM
Okay.
or whoever is playing the role of the PM. Could be a founder, could be anyone else, right?
Correct.
So this is where you need to talk to the PM and say, hey, I'm designing something. I want to know what we have ahead of us. Firstly, do you have clarity? If not, it's completely fine. I'll do whatever the best I can at the code level. If you do have clarity, please let me know so that I can design better.
Makes sense.
Anyone else would like to add to my answer? Ishan, anyone else?
No, I think I agree to your where basically if it's scheduled for, if you know that it's going to happen in the next couple of weeks, are very sure, then it makes sense to make it generic, spend more time on it. But otherwise, we don't know how future feature is going to work out. People would be using it or not. It doesn't make much sense to build it in a very generic way.
Right. One more thing I would add is what is the cost of making it generic versus not? So let's say building a feature takes 5 units of work. Okay. Could be 5 days, whatever the unit is, 5 units of work. Later on, if you make it generic, suppose you need to spend, I mean, no, you didn't make it generic, you built it in a specific way. Later
Correct.
on, you had to change it.
Correct.
And that takes 5 more units of work. So you have spent 10 total.
Correct.
Now, suppose you make it generic and it takes 6 units of work. And the later change takes 1 or 0 or like 0.1, let's say. It's very fast. Imagine changing the value of a named constant or something like that, right? It's very fast. So now you can say instead of 5, I'll spend 6. So that instead of 10, it will be 6 total.
But that's the thing, right? Like we won't know whether that function will require refactoring unless we get to that point where we know, okay, this can be reused here, but we'll need to put in effort of 5 days to change that.
So I'll give you a concrete example. People say you should have a named constant all the time. I don't really feel so strongly about it. If a constant is used multiple times, you shouldn't copy paste it, right?
Correct.
Because copy pasting may take whatever 5 seconds, but later on going through the code to find out where all your copy pasted can take hours.
Correct.
If you have to change something, right?
That is true. Correct.
So suppose you have a value whatever, right? What is the maximum score a person could have in a game? Like 100, let's say. Right?
Correct.
You shouldn't copy paste that value 100 in 100 different places. Right?
Yes, correct.
You just define a value const max score equal to 100. This takes very little time, maybe 5 seconds.
Correct.
Now, I don't feel the need to define name constants every time, because if a name constant is being used only once, it doesn't add much value. So let me just open an editor. So suppose you have this increase score. I'll just write Swift code, but the logic is independent of the programming language, right? Score plus equal to delta. Score is min of 4 and 100. Okay. Let's say I've earned 5 points in the game. So the score increases, but it can't be more than 100.
Correct.
Some people would say, no, this is bad code. You should not do this. You should do this. Final let.
Your screen is not shared, I think.
Oh shit.
Yeah.
So if you look at the code on top, which I've highlighted, in a game, whenever you earn points, your score increases. This function increase score is called.
Correct.
With a delta. So if your score should increase by 3 points, it will be 3 here. And let's say this is the logic. Score plus equal to delta. Score is min of score and 100. Okay. Because 100 is the max score.
Correct.
You can add a comment. Max score. Right? You need not write an essay. Shorter the better. Right? So some people say, no, this is bad code. You should do this. Right? In this case, it doesn't add much value, because you can make this refactoring from here to here anytime, and it will take the same time.
Correct.
So suppose you have written this code and submitted a PR and opened a PR. If it is used only here, I won't tell you, no, you have to use a named constant. Because if it takes 1 unit of work to make this change, it will also take 1 unit of work to make the change later on. So why do it?
Makes
Whereas
sense.
if I see you copy pasting this, then I'll say, no, we have to use a named constant, because then we are talking about 10 seconds versus an hour to later go through the entire code base.
Correct. Makes sense.
Cool. Any other questions?
Karthik, what's your opinion on continuous refactoring? Let's say uh, taking small refactorings every sprint versus uh, separate sprints, particularly dedicated to refactoring code base.
Both can work. If there's a lot of tech debt to be paid down, you can have a refactoring sprint. I would prefer to do things on a continuous basis though, because when you have a refactoring sprint, it becomes a big deal. The PMs will come and say, do you really need to do this? Can we skip it, etc., etc. It leads to a lot of conversations. It becomes a big commitment to make. Now, often we find opportunities for refactoring or bad design only when we go and change a code to implement a feature. So in that case, you should stop and refactor it, right? Refactoring should be driven by need. You don't wake up and say, aha, today I'm going to refactor the code. Unless you know there are problems, it's a different conversation. So when we work with code and we find a problem, it's a bad practice to ignore it and just implement the feature, because that is what the Jira ticket says. So when you're implementing a feature, any necessary refactoring that would make that feature easier to build should be done. So again, going back here, time to implement feature without refactoring. Suppose it takes 10 hours. If it was refactored, after refactoring, suppose it takes 5 hours. Refactoring time, suppose it takes 8 hours. Some people total it up and say 13. No, 13 is more than 10, so let's not do it. That's a short-sighted perspective, because this time you are spending will repay itself anyway. So it's like free time. Over the next few weeks and months, you are going to save 8 hours because of the refactoring. And if not, you shouldn't be doing the refactoring in the first place. Then it's a change for the sake of making a change, not an improvement, right? So you shouldn't look at it in a short-sighted manner, because the world doesn't end after you implement this feature. You have to live with this code base in the future, right? So yeah, so that is why I would say a Jira ticket tells you the outcome. It doesn't tell you how you should do it. And a PM is not the expert in code to say to refactor. So when an engineer goes and asks the PM, should I refactor the code? He doesn't know, right?
Yeah, agree.
It would be like a pilot in a plane asking me how much power level to use for takeoff. Like, I don't know. I would say maybe 100 sounds good, but if you ask someone who doesn't know, things won't work out, right? So what happens in these conversations? The PM says, no, man, how will that help? And the engineer will say something the PM can't understand. The PM will say, no, we have features to implement, let's not do it. And things will get worse and worse. So a Jira ticket tells you the outcome. If it says implement, sign in with Apple, let's say, then the outcome is that the user should be able to sign in with Apple. It doesn't say how you should achieve the outcome. You as an engineer are an expert in that. So you should use your judgment or talk to your tech lead or whatever and refactor it if it leaves the code in a better place without asking the PM. So that would be how I would do. So basically, long story short, continuous refactoring. So you can also have separate refactoring if there is one major issue which is independent of any feature, but continuous refactoring should be a habit for the team, is what I would say.
Agree.
Any other questions, comments? All right, then, for those of you watching on YouTube, if you found this useful and if you'd like me to upskill your team, my consulting link is in the description.